Alright, we're here, go to math.com, click on the calculus. How'd that get highlighted? I don't know, crazy stuff's going on in here. Optimization, what are we doing? We're doing 5, I think. What has got to do in the chicken farmer? So is a square base, okay. Ooh, we're using metric again, because that's what most of the world uses. Let's see, 5-1. Round answer to 3 decimal places. Find the maximum volume of a rectangular solid with a square base that has a surface area of 256 meters squared. Square meters, however you want to say that. So we want to find the maximum volume, so I'm writing this down, max volume of a rectangular solid with a square base, and square base has surface area, surface area is equal to 256 meters squared. Alright, I wrote it down. Has a surface area, square base, surface area, okay. It's a rectangular solid. I got the picture. Actually, let's sketch that picture out. Let's do our rectangular solid like it's a piece of ice or something. I don't know. Let's, it's a rectangular solid piece of ice. So we always want to draw, in physics we call this a free body diagram for some reason. Alright, I'll be glad when I get to that subject. I am going to be doing most of your science and math subjects at some point in time on here. So we'll go back to black here. It has a square base. That means this is x and this side here is x. And I can't remember exactly what I call this. When you work the problem out, we see the answer, but you know, let's just call this y. Okay, I may call it h, I don't know. Alright, now it's asking for surface area. Okay, that would be this side plus the other side. And we'll need to come up with that. But let's go over here. We're trying to maximize the volume. And the volume of this thing is, we'll say V is equal to, so we have x times y, right, to get the volume. So we'll say x squared times y. Now we're going to need to write, we'll let S be surface area. We're going to need to write the formula for the surface area, okay? So that's pretty easy. So we have x times x, so that would be the bottom dotted line, so we can't really see that in there. Yeah, we'll do this. Okay. So we have the bottom, right, plus the top. So that would be two of them. So 2 times x squared plus, and then we have, how many sides do we have? 1, 2, 3, and 4, right? So 4 times, and that's going to be x times y. Okay, x times y. And of course, this surface area is actually, they gave us that, didn't it? 256 meters squared. 256 meters squared. Let me just erase that right there. So I'm going to go ahead and write 256. Alright, so remember it's square meters. So now what we're going to do is we want to get this guy right here in terms of one of these variables, x or y. And I think what I'm going to do here is get everything in terms of x. So that means down here we want to solve for y in this problem. So this ought to be fun. So we have 256 minus 2x squared over 4x is equal to y. Actually, that wasn't too bad, right? Now, what I'm going to do now is take this and plug it into the volume. So we got v is equal to x squared, and then I'm just going to do a parentheses here, So we have 256 minus 2x squared over 4x. Now, good news is we can actually, since we have two x's up here and we have one down here, we can cancel one of these x's out here and cancel an x out right over here. What should we do? Let's just write it again. So we end up with, I'm going to go ahead and divide that by 4 and then put the 4 over here also. Okay, so we end up with x. You know what? Let's do this. Let's not get too crazy here. 256 minus 2x squared. Okay, and we don't want to skip too many steps at this point in the game. Now what I'm going to do is I'm going to go ahead and distribute this x across, and this is actually going to be pretty nice. So 256 divided by 4, is that anything good? Can we do anything good with that? Ooh, yeah, that's great. So it looks to me like 4 goes into 256 64 times. So we're going to have 64x minus, and then x times x squared is x cubed. But then we have 2 over 4, which is a half. So this is all working out. X cubed. So there you go. It all reduced down to that. Alright, so now what we want to do is take the derivative. 64 minus 3 halves x squared. Alright, and then what we want to do is set this thing equal to 0. And where can we do this? Can we just do this? Let's extend this problem up here so I don't have to keep writing. So we have 0 is equal to 64 minus 3 halves x squared. So let's take that over to the left. 3 halves x squared is equal to 64. How's that? And then we'll multiply both sides by 2/3. 64 times 2/3, right? Just bringing that, right, if I multiply this by 2/3, that goes away, and then you multiply this by 2/3, okay. Now, the question is, what can we do with this? I think 64 divided by 3 it's not anything nice. So, let's, you know what, I see something here. Let's just do this. So we have to write plus or minus, but of course, it's going to be the plus. That's what we're going to be looking for. Alright, and the reason I kept it like this is because I know 64 is a perfect square, right? Even though we are actually rounding and it doesn't matter, but anyway, you got 8 square roots of 2/3. Okay. Alright, so we got our x, and now we're going to need our y. And of course, remember y was equal to all this lovely mess up here. Okay. So, what are we doing here? We are, where do I want to write this out at? You know what, let's just write it up here. Y is equal to 256 minus 2 times, what are we doing here? Use that? I don't care what we use. 8 square roots of 2/3, and of course all that is squared, and that's over 4 times 8 square root of 2/3. Okay, so we want to use the exact value when we're calculating, when we're going to be approximating y there. Alright, now remember, and I need to add this because I'm not actually doing this to the problem. This is kind of something you need to do. But you want to put this, remember, on the number line, and then test if it's a min or a max. Now I'm telling you that we're trying to maximize volume, so it should be something that looks like Should be something that looks like that when you do your test points and everything. But I'm just mentioning that. You should actually try that out, work that out, okay? Make sure. Well, let's see. What is x anyway? We're approximating that, aren't we? So 8 times the square root of 2/3 is 6.5319. So x is approximately, I forgot what it was, round to 3 decimal places. Okay, so we get 6.532. All right, 6.532. And then, of course, let's go ahead and get the y, 256 minus 2 times that answer squared divided by 4 times 4 times okay, 6, and hold our breath. Man, did I just get the same answer? That's not even possible. I ended up getting the same somethings. I ended up getting the same answer. I don't know what's going on with that, but 4xh. Okay, so I'm using h instead of y there. Okay, so let's make sure we set that up right. That was 2x squared plus 4xh, right? That's right. And then h times x squared, yeah. And what did I get? I got, yeah, we got 6.532, and that is the same. That's what I got. 6.532. When we plugged it up there for y, which is actually h, I get the same thing. Okay, and then for some reason I went ahead and found the volume, I guess for the heck of it. Oh no, it says find the maximum volume. Huh. Forgot about that. So right, you would take those two numbers, put them in here. Okay. I'd probably do the two exact values, put them in here to find the volume. So there's how you do that. All right, pretty simple stuff. Well, maybe it's not simple, but you know, setting it up is the hard part, and then the other part you should be able to figure out. So come on over to GoToMath, practice that, and I'll see you later.